Taylor, and I'm going to walk you through graphing a piecewise function. So in this problem, it says graph the piecewise function below, and we have h of x equals 1/2 x minus 4 if x is less than or equal to -2, and 3 minus 2x if x is greater than -2. And so a piecewise function is going to have two pieces. It's divided by -2 and -2. Sometimes they can have more than two pieces, but in this case we only have two. And both of these equations are linear. They're in the form y equals mx plus b. So that means that any number in m's places are sloped, like 1/2 and -2. And anything in b's place is your y-intercept, like 3 and -4. So that's really going to help us graph. And when I graph, I like to graph the whole line and then just erase for a piecewise function. So I'm going to graph 1/2 x minus 4 first. And then I'm going to graph 3 minus 2x second. And then I'm going to do some erasing wherever our boundaries are defined by the inequalities here. So first you start with your y-intercept. So in this one, my y-intercept is -4. So I go to -4, 1, 2, 3, 4, put a point. And then from there I use the slope, which for this equation is 1/2. So it's rise over run. I rise 1, go to the right 2. So from my y-intercept of -4, I go up 1 over 2, up 1 over 2, up 1 over 2. And then I want to extend to the left as well. So down 1 over 2, down 1 over 2, over 2. And then I just connect my dots. Okay? And now I'm going to graph 3 minus 2x, which is this line here. And my y-intercept, even though it's written in reverse order, the term that's multiplying the x is still my m. So that means my y-intercept is still 3. So I go up to +3 on the y-axis. And then I use -2 here as my slope. And anytime you have a whole number for slope, you always put it over 1. And if it's negative, instead of going up and to the right, we're going to go down and to the right. So from my y-intercept, I go down 1, 2 over 1. Down 1, 2 over 1. Down 1, 2 over 1. And then to create my line in this direction to the left, up 2 over 1, up 2 over 1. And then I just connect those points. Now, those are my two lines. However, now that I'm familiar with piecewise functions, I know that I have to do some erasing, because if x equals -2, my line changes from here to here. So I have to figure out what to erase. Well, for this line, 1/2 x minus 4, which is this line here, it is only defined for this function when x is less than -2. So that's all values to the left of -2. So that's here. And so this bottom line for this function only exists to the left of that x value. So anything to the right, I have to erase. So get rid of all this. So that's anything to the left of x equals -2, because we're talking about less than. And it's got this little equal to sign, so I use a closed circle at x equals -2. Now, my second line, this one here, this 3 minus 2x line, it's only defined for this function when x is greater than. So that's to the right of -2. So I go to -2 up here, and anything to the right stays, but anything to the left gets erased. So erase all that. And see how this is just greater than? There's no equal to symbol. That means I put an open circle. And so this would be the graph of my piecewise function. When x is less than -2, in this direction, it's defined by this line. And when x is greater than, which is to the right of -2, the function is defined by this line. And that's how you graph a piecewise function.